Assalamu alaikum wa rahmatullahi wa barakatuh. Good day everyone. Welcome to my network infrastructure management paper review presentation. Today inshallah I will be presenting a very relevant and recent journal paper in the area of multi-cloud and hybrid networking. The paper I have chosen is titled Convergence of AI and Zero Trust, Enabling Continuous Verification Across Hybrid Cloud Environments. This paper was authored by Barinda Parsa and published on April 15, 2026 in the International Journal of Intelligent Systems and Applications in Engineering. I selected this paper because as enterprise networks rapidly transition to complex hybrid clouds, traditional perimeter-based security is no longer effective. This paper provides modern cutting-edge solution by merging artificial intelligence, that is AI, with zero trust architecture to secure distributed networks, which perfectly aligns with the current trends in our syllabus. Let's move on to the summary of the paper. The core research of this problem that was identified by the author is that contemporary organizations, different companies, are struggling to defend themselves against sophisticated threat actors across distributed hybrid cloud environments. Specifically, human teams cannot maintain the velocity required to continuously verify millions of daily authentication decisions through manual security operations. So, the main contribution of this study is that the integration of artificial intelligence, that is AI, into zero trust frameworks to enable viable continuous verification. The author provides actionable, autonomous, and AI-powered authentication and authorization systems. Next, let's look at the technical approach used in this study. The author developed a 5-layer reference architecture that explicitly integrates AI components with zero trust pillars across hybrid cloud platforms. These 5 layers, I'll be mentioning them. These 5 layers are data collection, analytics, policy decision, enforcement, and orchestration. By categorizing the network into these layers, the system can continuously monitor behavior and enforce security policies dynamically. Furthermore, the methodology includes a 3-phase implementation framework. This framework was not just theoretical, it was synthesized from 8 documented enterprise deployments, providing a quantified and structured approach for network administrator to deploy this system. This was a very real-world protocol and it is effective. Now, let's discuss the critical analysis of this paper, starting with its strengths. A major strength of this research is that it is highly empirical and practically validated. The author's mitigation strategies are evidence-based and were validated through expert consensus with 12 CISOs, that is, with 12 Chief Information Security Officers. Additionally, the paper features a robust cross-sectoral deployment analysis across 5 different industries, giving it a tremendous and great credibility Please, I'll be mentioning the weakness also, but please note that the following weakness is my own analytical insight and it is not drawn from the source material, so that you may want to look for the reference or verify the perspective. A weakness I identified is that while the paper provides excellent metrics for massive enterprise deployments, it does not seem to deeply address the computational overhead, energy costs, or financial feasibility of running continuous AI-driven verification for smaller organizations or highly constrained edge environments. Moving to my proposed improvements, the modification I made is from me actually, not from any provided source. So I suggested two modifications that I jotted down. The first modification suggested by me is integrating federated learning. Instead of centralizing data collection of the AI analytics layer, federated learning could allow different hybrid cloud nodes to collaboratively train the threat detection AI without sharing sensitive underlying network data, thus improving the data privacy. The second improvement suggested is edge device optimization. I propose extending the 5-layer architecture to encompass lightweight version of AI model, specifically for IoT and edge device, ensuring continuous verification, which is the absolute edge of the network without causing massive computational strength. Now, what is the real-world relevance of this study? Moving to my proposed improvement. The findings shows that the convergence of AI and zero trust has a massive, measurable impact on real-life operations. The study demonstrated industry-specific operational improvements ranging from 30% to 75%. These improvements were measured across vital sectors, specifically manufacturing industry, financial services industry, healthcare industry, retail, and energy industries. In real-world applications, implementing this architecture leads to significant reductions in misconfiguration incidents and vastly improved threat detection times and the capability for automated incident responses. It is also results in substantial operational savings for companies managing multi-cloud environments. So I'll come to my conclusion. In conclusion, overall, my impression is that this paper represents a critical milestone in cloud networking. It provides conclusively that human-driven security operations are obsolete for modern multi-cloud networks. AI-powered continuous verification is operationally and financially beneficial, and it is necessary standard for protecting our generation enterprise infrastructure. So this is all my review. My reference will be shown here. Okay, thank you for watching. Okay, thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.